Hello viewers, welcome to my YouTube channel Engineering Lab. Today we are going to design a variable power supply using Proteus. So let's start our project. So we open a new project so that we can write the name of the project which we want to make. So on the name, it's a variable supply. Okay, let's click next. It's a schematic only. So let's put the components which we would like to use. So first of all, we need an alternator, that is the input signal. Alternator is right here. Then we need a transformer for stepping down the voltage. Transformer, we just need a simple transformer, this one. Then we also need a capacitor for smoothing, this one. We also need a polarized capacitor, this one. Then we also need some diodes, rectifying diodes, one in for 007, this one's for rectification. We also need a resistor, this one. And our regulator is we're going to use AOM 317. We can use this one. This is the regulator that we are going to use. We also need a potentiometer. Let me choose this one, this type of potentiometer. Right, so for now let's try to place our components on our workspace. So we start with the alternator. This is the input AC signal that we are going to have. Then next, the transformer, we are going to put it right here. Then we put our diodes for rectification. So we are going to make a wave bridge rectifier. The other one, let's put it here, the other one here, and the other one here. So let's try to rotate them in a way that we create a wave bridge rectifier. So like this, we are done. Let's do the wiring, the connection. Okay, so the rectification is for converting AC signal into DC signal. So here let's connect the AC signal to the transformer. So for the input section, this is our positive output and this is our negative output. So we connect the input section here, and we try to, and this one is our negative section, our input section, sorry. So let's next we are going to put our capacitors for smoothing the DC output. So this is the first one. We are going to put the other one right here. So let's try to rotate them. Let's rotate it clockwise. This one again clockwise, like this. Therefore we just try to move it next to this one, right? Then let's put the resistor. resistor right here, and let's rotate it clockwise. Then we have left an LED. You can put an LED, a red LED just below the resistor. Let's put it right here like this. Then we'll put our regulator right here, our RM 3710. Then we put our resistor again. Need a resistor here. Then our potentiometer, we are going to put it just below pin 1 of the regulator. Then we also need the polarized capacitor here at the output section. So let's rotate it clockwise like this. So let's do the wiring. So from here we are going to connect here, then here. So this is the positive section of this one is connected to V-in of the regulator, and here we connect her to the LED. Then this one is our ground. This is our negative. This section. So when we have two anodes of the diodes facing each other, it means that's our negative. So let's connect these components to the ground. Then this one is connected to pin 1, and it's connected to R2 again, and R2 is connected to V out. So this ground is then connected to the capacitor C3, and connected also to V out, and this one is connected to the ground again. So this is how the circuit looks like. So we are going to change the value of the capacitance and the resistors, because if we work with these values, our circuit may not function well. So for this one, I'm going to put 1200 microfarads. Then for this capacitor, we can put 200 microfarads. Then for this resistor, we can put 1K, and for this one we can put 240. Then this potentiometer, we can make it 10K total resistance. Then this one we can make it 100 microfarads, 100 microfarads like this. Therefore we are done with the at the input value of the amplitude. Here it's 220, we use 220, and for the frequency normally use the 50 Hz. Then we click OK. Then for the circuit it's done. So let's try to put we can put a voltmeter, a DC voltmeter, so that we can measure our output voltage. This one is a variable power supply, so we should be able to change the value of the voltage which we want at any point. So let's try to simulate. There is nothing going on right now. Let me try to put the ground terminal. I didn't put the ground. Where is it? Yeah, let me put the ground. I forgot to put the ground. Alright, as you can see, it's now running. So as you can see, the LED is on. So this is our input section, and this is our rectification section, converting AC to DC, and this is our smoothing capacitors, and this is the regulation part, and this is our output. So as you can see, our output is 33.5 volts. So we change the voltage by varying here the resistance here, so we can try to decrease the resistance. You can see that the output voltage is also changing as we decrease, and it's showing that it's increasing. So as we increase right here, you can see that it's now decreasing. It's at 36 volts. It's not decreasing. You can decrease it as far as about 40, from 0 to 40 volts or above. So that is how you go about it when designing a variable voltage supply. So this is how you do it. So thanks for watching. Don't forget to like and subscribe on my YouTube channel. In our next video, we are going to do the PCB layout, so that we can know how we place the components on our PCBs after the schematic capture. So thanks for watching. Don't forget to subscribe.